talking about data cleaning. Data cleaning is the most important part of the entire machine learning process. Garbage in is garbage out. Data cleaning is one of the most important and longest steps of data science. Here is the data science cycle in the extract, transform, or load cycle. At first we have data gathering, then we have data cleaning. That's what we're going to be focusing on in this video. Then we have data exploration and visualization, which sometimes intermixes with data cleaning. Then we have model development and model deployment. So what is data? Data is the poop of business. And if you haven't seen the video where it shows the whale eating everything and pooping Rubik's Cubes, then you should watch that video first, and it's up here. Right there. That video. That's the one. But either way, if you don't clean the data, it's poop. And doesn't matter what you mix it with, it's still just going to be garbage. Because garbage in is garbage out. Data is the currency of kings. The kid with the most Lego sets wins. And that's what data science is like. We take a big old box of Legos that are all mixed up together with different colors and stuff, and we sort them out, and we separate them, and we tally them, and we're able to tell a story with them. That's what's cool about data science or data cleaning, is we're able to tell a story from data that others can't see or tell. All sorts of places in the United States are taking your data, and they sell it. It doesn't matter what the data is. It could be continuous numbers, categorical data, images, text, LiDAR, or audio waves. It really doesn't matter because at the end of the day, it needs to be transformed into binary. Big data is generally dirty, and dirty data is represented as this unsolved rubriks cube. Solving a rubriks cube is a really good analogy for data cleaning. Here are the 8 steps of data cleaning. First one, understand your data. Second one, you have to handle missing values. You have to either drop them or fill them with something. Then you have to check for duplicates. Then fix data types. Then standardize and clean the values. Detect for outliers. Validate that the data is clean. And document the entire process. Here's an example of dirty data in the wild. Notice that it's got 3 columns: name, age, and married. Notice that there's duplicate columns. Notice that there's numbers where there should be names, and letters where there should be ages. And the married is yes, no, why, and there's no consistency. This is how we clean the data. This is how we solve the Rubik's Cube. The first thing we do is we drop the row with the 6 and the NaN. Then we drop that last row because it's a duplicate value. And then we convert the married column to binary. We lowercase all of the letters, strip the white spaces, and left align the names. That's one of the first parts of the tokenization process, prior to a large language model or corpus text processing. But that is outside of the scope of this specific basic data cleaning. And lastly, we ensure the age column is an integer format. When we're all done, this is what the clean data should look like. Notice that the name is all lowercased. It's all left aligned and stripped of white spaces. The age is all a consistent number, and married is either a 0 or a 1. The data is now cleaned, and the Rubik's Cube is solved. Next thing we do is we visualize each side of the Rubik's Cube. Sometimes we have to visualize to find outliers and then re-clean. It's always an iterative process, and each data set is going to be different. So don't be surprised if you're having to visualize, then do more cleaning, export to Excel, and do more cleaning. It's all part of the process, but you have to stay consistent. Finally, that solved Rubik's Cube is put into a machine learning model. That machine learning model is then deployed wherever you want it to be deployed to make classifications or predictions on whatever you want. Also, that solved Rubik's Cube is a digital asset, because it's like statistical jet fuel. Here's an example of the data cleaning process going from crude data and being produced into a data product. Notice that JSON is the least valuable of the data products. Usually JSON is nested, so it has to be put through more rigorous cleaning, and I don't necessarily consider JSON a cleaned format. Next is the text file. It's like kerosene. Then there's the Excel file, like gasoline. But the most important files are CSV files. That's what the machine learning models love to eat. That's their favorite food, is the CSV, the comma-separated values file. That is statistical jet fuel. For another class, we have parakeet and feather. and this is outside of the scope of basic data cleaning. And here's the final slide for you all to know before I pass you off to the next teacher. These are the libraries that you're going to need for any basic data cleaning in Python. Remember that polars and pandas. Remember the bears. The bears are the ones that manipulate the data. Polars are for really big data, and pandas are for smaller data, but still big data. Next, you're going to need NumPy. It's pronounced NumPy, not NumPy. NumPy is a library that was made for accountants. What NumPy does is it takes an entire data set of numbers and converts it into one NumPy array, which can be manipulated and visualized and explored in different ways. Last but not least, Seaborn and Matplotlib are two really nice to have visualization libraries that are essential for any data scientist or any data miner out there cleaning data for the first time. And I know what you're probably asking. Do you need a helmet? Not necessarily, but I do, because safety is first, and I wear an OSHA-approved data mining helmet. Thank you for watching this video all the way to the end. I am your Professor Data Miner Mole, and I'm a hardworking rodent, and I deserve subscribers, so be sure to subscribe, because that costs you nothing, hurts you nothing. Be sure to like this video and share it with all your friends. Be sure to smash that bell for more data-driven updates. Bye!